We'll continue on chapter 2 today. We'll finish chapter 2, and if the time permits, we'll go for chapter 8, environmental toxicity and of the toxic effect on that's chapter 8. But here we'll just look at the chapter 2 is really covering the cycles of elements that's really contributing to the sustenance of the environment and the living creatures. So, and those elements, as you can see, and some molecules. This is H2O here. We speak about the hydrologic cycle, this cycle of H2O. Then we'll be looking at phosphorus, nitrogen. Those are very crucial in the sustenance of life on this planet. So the hydrologic cycle is a cycle of the H2O in the whole our planet. So we'll start with the ocean. That's what we have. The majority of our H2O is salty ocean H2O. The sun will come and evaporate as the tabor up. The tabor will go up as fogs. The wind will come and push those fogs all over the places over land and mountains. Then we'll have rain. Then this rain will come down on the mountains and the soil. Part of the tabor from this rain will be sieved into the ground and make aquifer, or make the ground H2O inside, and some of it will seep back to the ocean. So we have a cycle. We have a cycle. So if I will just have this one here, as just imagine this one here. So here you start with the ocean, because that's the majority of H2O in this planet found in the oceans. I will say maybe over 85%, and the 20 something or 15 to 20% is in the ground, correct? But the majority of our H2O comes from the ocean. So let me see here, show you here. I start with the ocean here. Oops, sorry. I have to make a bolder or medium so you can see it. So here's the ocean. I'll start with the ocean. H2O. That's tabor but salty. It has a lot of magnesium and calcium salt. Nitrate, mostly nitrate. Magnesium nitrate and calcium nitrate, making this salinity of tabor inside the ocean. So then the sun will come here. The sun will come and hit this ocean, correct? Then out of this one here, you will find the ocean now, because of the heat coming from the sun. This H2O. H2O is what? That's a molecule structure. This is structure of the tabor. So H2O will evaporate as vapor or steam, as vapors. Oops, sorry. These vapors here make what? Clouds. This H2O here will come and make clouds. The clouds will come now by the sun. Again, by not the sun. Now it's the wind roll to move this vapor out, correct? This cloud H2O. It's cloud H2O. So vapor is thinner in density, but there will come, when you go up, the temperature is decreasing, so the H2O start condensing, making clouds. So the cloud is, what is really a cloud? The cloud is just tabor, and start condensing because the temperature is at higher elevation will decrease. So this temperature is cooler up there, so you get H2O clouds. These clouds then will come and collide among themselves. Positive cloud versus negative cloud. They're then you get all this lightning and everything. At the end of this cloud collision, here clouds collision, we produce, then come back H2O. This time is just rain, will come down as rain, correct? This rain will go here in the top of mountains, and the ground of this will go on the land soils. So this is a cycle. Part of this H2O at the mountains here, and H2O at the soil. So part of this mountains here, part of it, the H2O at the mountains will seep into the ground, correct? Seep into the ground, go to the ground. We can get it out by digging wells, tap water wells, and part of it will go back to what it is, to the ocean, back to the ocean. And in the soil, the same thing. Part will be received into the ground, and part of it will go to the ocean. Now, if we have thus the temperature will decrease further, so then this collection of clouds will make snow on the mountains and on the land. Snow here, snow, and this snow at the end will come up as, this is a solid H tabor, so the snow is just frozen H2O. Snow is frozen H2O. When the temperature is increasing enough, you get the cycle back. This part of it will go to the ground, and part will seep to the ground because you have a porous rocks. So H2O is a small, tiny molecule, can go through those porous rocks to the ground. And this will remain for many, many years, for thousands of years, unless it's depleted by humans or by any volcanoes or earthquakes or whatever natural mishaps. And part of it will go back to the ocean. And this cycle goes back and forth, back and forth. And that's really sustaining the life on this planet. Without this cycle, nobody will be able to live, because if just the sun with too much of heat, and H2O is so hot, steam, not vapor, steam, that's over 120 degrees. Suppose the sun is coming close, the whole ocean will evaporate, and they will go out of side the earth in the universe somewhere, correct? But that's the way it's maintaining our life on this earth. So let me take this one here and just show you here just the cycle here. And this is the same here. This is just a cycle here. You can see it. The ocean evaporated. The wind will come and push this one here, and then you get those vapor at higher temperature will make clouds. Those clouds will come, and negative clouds, positive clouds, they collide, and you have rain. This rain will go on the mountains and will be part of this, and the mountains will seep into the ground, or will go direct to the oceans, because we have some mountains very close to the oceans, correct? Whenever they have the tabor there from the clouds, some of it will seep into the ground, some of it will just go to the ocean. And some of these clouds, rain, will come and go to the soil. The same part of it will go to the ocean, and part of it on the ground tabor, correct? So this is just a cycle of H2O, and that's very crucial to maintain or sustain a life on this planet. As you know, H2O is very crucial for many creatures and living bodies on this planet here. So, any question about H2O cycle? H2O cycle? So the main thing is you have to have the sun there. Yes? What's that? Translation? Where is it? Transpiration from vegetation. Yeah, those some vegetation when they can produce, but that's more tiny amount. And some fungi and bacteria through their chemical processes, and even humans sweat. They're sweating, and literally some of these trees can give because of the heat and temperature, they can give away some small, but this is small, tiny. Their contribution is very minimum. You can't expect from the trees that they get you a lot of H2O. But some they do, some they, but that's in general small. But the major one is from the ocean. The ocean is the 80% or more. You can Google the percentage, but I think more than 80% of tabor inside on this planet. So the tabor inside this is the only problem with it is has a lot of salt, magnesium nitrate and calcium nitrate. You don't have to worry about magnesium, but that's the salty H2O. We call it salinity of the oceans coming because of the presence of magnesium and calcium nitrates there. So now when you evaporate, you don't evaporate the salts with you. No, the salts will remain inside. Okay, you just evaporate the H2O small molecule. The salt is very bulky, very big, cannot be evaporated with the tabor. You evaporate just vapors. Those vapors, when you go high elevation, temperature decrease. So they come together to make clouds. Those clouds can be positive charge or negative charge. So they will come together and they collide, and then you get out of those rain. Of course, those clouds are driven by wind all over the planet, on the mountains and on the land, soil, and part of it will go back to the ocean, and part go to the ground. Now, if the ground is depleted for some reasons, that will lead to drought. You heard about drought. Some areas are suffering because they have a lot of earthquake in that area. Earthquake will just push the H2O platform out and break the hole through, and then this ground H2O will go back to the oceans. Correct? Will go back to the ocean. So it's a cycle. It's a cycle. You can see it. It's a cycle. But the major contributor is the ocean tab H2O. All the other stuff is just is an effect of the evaporation of the small molecule H2O, leaving the salts inside the ocean. Correct? Leaving the salt inside the ocean. The salts are not going anywhere. Magnesium and calcium nitrate, they remain inside so the area where there is a lot of evaporation, it will be very salty. If you go in the ocean, some areas different from other areas. Not the whole ocean is 100% salty. It depends on the amount of evaporation. The more you evaporate, the more concentrated the salinity will be, the higher the value of salinity will be. Correct? You can check even some rivers. In some rivers, the same thing. Although this is sweet H2O, but still some rivers, because they will go back to the oceans. You see the area where the overlap between them and the rivers and the ocean, salinity will start increasing compared when you start at the beginning of the river. There's almost zero salinity, very sweet, you can't drink it. But when you come closer from the river to the ocean, that area salinity will go high. We went longer time with our science club to the savannah. They have UGA research station there. We took a boat, and they measured the salinity, the beginning of the river in the savannah. From the savannah area, it goes to the ocean, Atlantic Ocean. And it was astonished that the salinity is different, not the same. When you approach the ocean, salinity of the river starts going up, 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 and then it pours itself inside the ocean itself. So, the carbon cycle, well, the carbon cycle is mostly coming, where do you think a carbon will start from? Now we know that deposits of carbon can be found in the soils, correct, through the millions of years due to higher temperature, higher pressure, correct? Those higher temperature, higher pressure makes out this carbon as a carbon element, make out of it crude oil, correct? The crude oil, what is crude oil? Crude oil is just deposits of carbon through millions of years, through higher pressures, higher temperatures inside the soil, coming together to produce carbon and then compressed and then other compounds. So the crude oil is not one compound. It's a multiple, hundreds of compounds together. And it has different densities. Some of the crude oil is heavy density, will sink at very lower deposits, and some of them less dense will be in the upper. So the carbon cycle begins with the photosynthesis. The photosynthesis, as you can see, is the whole idea of photosynthesis is making glucose, making sugars, which the plants, the main producer, are living on. They need sustenance. Their food is coming from the carbon dioxide in the air, and with the help of moisture, H2O, and then the sun. So you have all this glucose, sugar will come out. So you don't have to know about this, but this is carbon dioxide is here, from the air is coming. So here it is, and you have moisture, and you have to have sun. Without sun is the plant, the major producer, cannot produce glucose. You produce a sugar called glucose, and this glucose is C6H12O6, and the structure of it will be looking like this here. You don't have to worry about, but this is the structure of glucose here. That's not a chemistry class, but at least you know. So you can see how complex, small, tiny gases. H2O is vapor in the air, moisture, and CO2 is a gas. Both of them are vapors. Both CO2 and H2O are vapors. With the help of the sun, you need the heat. You need energy to drive this type of reaction. So then the plants will make for themselves glucose. By the process, they're producing what? Energy itself. So you get glucose, and the energy will be produced. So you can see how the carbon is for the plant. The photosynthesis is, that's the beginning of the cycle. So, but as I said, the major deposits of carbon is inside the soil, inside the caves, inside the deep in the mountains. Those are millions of years of deposits of carbon there. And then when you have those are exposed to, for some reasons you have an earthquake, then you have an oxygen coming in. The oxygen will come and react with the carbon deposit to make carbon dioxide, correct? So, this type of photosynthesis here, producing of glucose for the sustenance of the producer, we are consumer. We are consume our food from the plant, from the main producer. So the producer is really helping to fix carbon. So this is fixation of carbon. This process here, making a glucose, releasing energy here, that was called carbon fixation. The sugar molecule, that's the glucose, is absorbed into bloodstream of animals, because the animals is consumers. They are feeding themselves on the whatever the producer is made from grass, whatever producers make of fruits or veggies or whatever. So the consumer are feeding themselves, and through this process you will find this glucose is inside. So they are taking this glucose, which is very important. Very important. Is one of the most important chemicals in living creatures is glucose, correct? It's glucose. So, and you can see it's controlling a lot of stuff in humans and the other creatures. So that's called sugar. You heard about the blood sugar? The blood sugar, that's a glucose. When its concentration in the blood too high, that causes the blood pressure to go up. The same effect if you eat too salty food, the sodium chloride will affect the same effect, but glucose is very important. Sodium chloride is not really a major food for the blood cell and for the brain. Glucose is. If the brain lacking glucose, you'll be fainting, you'll be dropping down on the floor without no control in your brain. So the glucose is really the major of nutrition for the living life on this planet. So it's made from the photosynthesis done by the plants. We are coming and feeding ourselves with the fruits and veggies. They have those glucose stored inside them. And this, as I said, all this glucose is going in the blood pressure, is controlling with the help of other hormones, controlling the amount of it, is controlling a lot of activities in a human body and in the other creatures, living creatures as well. Carbon dioxide, if it's used in respiration, it may be exhaled as CO2 in 1 hour or less, and plant could take up to that much of time to exhale CO2. So the plant, whenever they are making the CO2, glucose energy and the oxygen will come out. Here I forgot to add the oxygen here, plus the oxygen. So maintaining the oxygen is through it's not said in the slide, but oxygen is maintained indirect inside the universe through this photosynthesis, because the carbon dioxide is taken by the plants, giving itself some food, glucose, energy, and oxygen will come out. Oxygen will come out as well. So the carbon atoms from the sugar molecules could remain as part of the body until it decays after death. So glucose is still remaining in our bloodstream. It cannot go out, because that's the most important feeding chemicals for our brains, for our body. We need the glucose there. So until somebody is dead, then the whole thing will be decayed by bacteria or fungi inside the soil. Then the body will be just decomposed by the bacteria inside the soil. The same thing about carbon in the wood, carbon in the deposits, in the mountains, in the caves, in the soil. All those are released as carbon dioxide. Now you ask yourself, how is carbon deposits, it's like rock in the mountains, deposit the CO2? That's happened through earthquakes. Sometimes you see earthquakes are mishaps for us, but however, earthquakes are very useful to produce CO2 gas, which is needed to produce glucose by the plants, which is we are feeding ourselves from this plant glucose. Are you following me? It's a cycle. So really, if you look at this, we need the earthquakes. We need to get these deposits of carbon outside the soil as CO2, and the earthquake will do that for us. As soon as you have earthquake, you have oxygen will come from the air to react with high pressure, high temperature with carbon deposit to make carbon dioxide. Recycling may take a very long time. Fossil fuels like coal, crude oil are are the remains of organisms that lived millions of years ago. Their carbon atoms are not released until the coal and oil are burned. That's what I say. That's what I remember. But don't be upset. You are eating your lunch. Whenever you eat an apple or any veggie or fruit, remember it's coming from dead bodies through the years, or from just the structure of the earth or our planet or whole universe structure came with those elements. Carbon is the most important element inside this universe, so it's there. But it's the volcanoes is sometimes not a mishap. That's a good thing to have volcanoes, so we can get some of the carbon deposit out as carbon dioxide, which then will be fed by the plants. The plants then give us glucose, and they're releasing oxygen in the process and energy. Well, the nitrogen cycle is the same thing. The nitrogen is the nitrogen is coming mostly from the soil, and special fungi and bacteria is really working on this. It's not like you'll see that caves are filled with nitrogen. Nitrogen is an element that does not like carbon. Carbon likes to be a solid by itself, like a rock. Okay, like brown coal. Brown coal is carbon, but you'll not find nitrogen. Nitrogen likes to be salt, like to be gas. This gas will come and be dissolved inside the soil by the rain. Take this nitrogen from the air. The air is about 75% nitrogen, so the air will come and push this dissolving nitrogen inside the soil, and this then you will have inside the soil ammonium, you have nitrate, you have the ammonia, the nitrite, the nitrate. All those chemicals are minerals needed by the plants, the producer growth. Anytime you will see that the plant is not growing very well, then you will know that it's lacking nitrogen. This plant is lacking nitrogen. Then you will go to the store to bring a fertilizer that's rich in nitrogen and phosphorus. As I said, those are the major two elements that's the plants, the producer of our food. We are consumers, so that's what they feed on. As ions, not as an element. Nitrogen does not like to be an element, always as a gas. Gas will be dissolved and then produces those ions, nitrate, ammonium. Those are very easy. Those ions are very easy. Go through the stem of the tree to the leaves and all over to the body of the plant or the plants. But nitrogen as a gas will not do that. It has to be converted through the fungi and the bacteria to produce ions, which is they can seep from the soil into the stem of the trees and plants. So, and you can see those are nitrates, very important, nitrogen. So when you buy a fertilizer, you don't buy it as nitrogen. It said nitrogen phosphorus fertilizer, but this is phosphate as ion, sodium phosphate, and then you buy potassium phosphate, or you buy a potassium nitrite or potassium nitrate. That's your fertilizer. It's not per se this, but those are containing nitrogen there. So the plants absorbing nitrates and use them to build amino acid and eventually proteins. So that's what the plants are doing. Not only they are producing glucose, which is needed for glucose is really used by the body to restore or to maintain the balance of energy inside our body. But you can see the same effect can be seen by the plants as well. So you get those nitrogen and phosphorus ions which affect the plants themselves. If they lacking those two elements as ions, then you'll see they will die, or just you can see their leaves turning to yellow, even in the summertime. In the summertime, you will see their leaves looks very sick, meaning you can tell that they are lacking what? Nitrogen and phosphorus elements there as ions. The nitrogen cycle, the plant proteins are consumed by animals. Okay. What is protein? Somebody will tell me what we mean by protein. What we call protein. What we can use as human protein for. What's that? Muscle. What is protein then? Protein is amino acids. It's not the chemistry, but that's, at least you know, somebody will ask you, what is amino acid? Well, amino acid is carboxylic acid. This is carboxylic acid that has amino group in it. So this is the simplest amino acid. The simplest amino acid. This is amino acid. That's a very simple one. Now imagine if you have amino acid with 20 carbons, 30 carbons. That's a very complex amino acid, which is really a major producer for muscles inside the muscle tissues, and our DNA, RNA in our bodies is really made of those amino acids. Not only the muscles, but it goes even to the content of the cell itself, the body, whether it's red cell or white cell. So that's the amino acid. That's the simple one. So that's the simple structure. But if you have more than 2 carbons, then it will be even more complex. So you don't have to worry. I'll just give you the whole thing. And now, if I combine, that's amino acids. If I combine many amino acids to peptide link, if I combine too many amino acids through a link bonding called peptides, I'm producing protein. That's now I have a protein. A protein is a combination of several amino acids together, linked by peptide bonding. But at least if you get the idea, it will not come in the quiz or exam, but at least people, they know protein is used for the muscles, but they don't know what's really protein. Protein is amino acids. Several of them are connected together through a linkage or peptide linkage or bonding. Nitrogen enters the environment through the death of organism, of course. That's many as even sulfur dioxide, sulfur trioxide, hydrogen sulfide, all those sulfur, phosphorus, nitrogen, all those coming out from dead corpse. When you have a dead corpse, the fungi and bacteria try to enjoy their food on this dead corpse. By this process, they are releasing those elements inside the environment itself. Correct? So this then will react with oxygen. Then you get this nitrate and nitrous oxide and all other stuff. So that's the whole major thing. Major thing is dead corpse, dead bodies through the years, eaten up by or worked or decomposed by fungi or bacteria, and there are those nitrogen and as well as sulfur, as well as phosphorus. Many will come as an element, then will interact with the oxygen to produce ions, to produce phosphate or nitrate, for example, or H2S. So, yeah. This is just show you here the trees. They have those bumps or like bulbs, small tiny bulbs at the bottom, their roots. If you can look at those bulbs, can you see them? Everybody can see them, correct? Those are like small tiny spherical object here, or just balls a little bit. So those are those will be fed by the fungi and bacteria, and then you can see they release nitrogen inside, to the environment. So nitrogen is converted to usable form, and nitrogen as a gas coming from the fungi or bacteria eating dead corpse through the years, and then they're releasing nitrogen. Now nitrogen can interact with oxygen to get all this nitrate, and the same thing with phosphate. So each nodule is a mass root of tissue containing many bacteria that helps convert nitrogen in the soil to form that bean plant can assimilate to use to manufacture amino acids. So amino acids. Amino acids is different from glucose. Okay, amino acid is the building structure of the cells. Glucose is maintaining or controlling the energy inside the body. Correct? So that's the difference between the protein amino acids and the glucose. Glucose towards energy, correct? And the proteins are about creating new cells. So new cells, muscles, especially muscles, amino acid. Correct? So that's the difference between, whenever it comes to your idea, glucose, remember the energy here. It's really conserving and in maintaining the energy inside the living creatures. And it's really, because it will be burned and you get CO2 when you exhale CO2 and you inhale oxygen, gets out CO2. From where is the CO2? Well, you have a glucose, you have eaten glucose. So it's really maintaining the energy type. And the protein is the manufacturing of new cells. That's the difference between the two. So phosphorus, we talked about phosphorus. That's in combination of nitrogen. So again, you can have this one here. The dead corpse will be eaten up by fungi. The same idea, nothing really new. So they will be then transformed with the help of the fungi into a form of phosphate. This phosphate is a major nutrition for plants and consumers. And then we come here as a producer. We feed on whatever is the producer's made, and then they come in our body as phosphate, correct? As phosphate. So, and this is the same thing when we die, we come back again. Our dead body will be eaten up by decomposed by those fungi and the bacteria, releasing phosphorus, nitrogen, all those as gases. Then when they come with the help of further fungi and bacteria, they are decomposed to the ions. The plants will never feed itself on pure elements. Carbon, like brown coal, is not. Or phosphorus, phosphorus, cannot be eaten by the plants. It has to be transformed into ions. So then the ions can be soluble in H2O, and then it will go to the stem of the plants itself. Correct? So it's the same phosphorus, carbon, and sulfur. It's the same type of cycle. The sulfur cycle is the same thing. Dead bodies and coming even from the rocks and minerals, they do have carbon, they do have phosphorus, they do have nitrogen, minerals, correct? And through the emission, weathering, earthquakes, volcanoes, you get those as sulfur dioxide into the air, and then they come back with the interaction of H2O. You can produce what you can produce, acids. So what's acid rain? So areas near volcanoes, correct? Areas near volcanoes are always subjected to acid rain. And some power plants, but the power plants, they are they are under restriction because they cannot release all the junk stuff into the air because these regulations will prevent that to happen. But if you have an area that's near a volcano, you get an acid rain area. That's whatever sulfur is coming out will be reacting with the air. Oxygen creates sulfur dioxide. In the air you have moisture. Sulfur dioxide come back as sulfuric acid. Nitrogen will decompose by the fungi, goes with the air to get nitrogen dioxide with the moisture air, the moisture H2O will come back as what? Nitric acid. So a combination of sulfuric acid, sulfur, and nitric acid, nitrogen, this is called acid rain. So, and that's special areas near volcanoes. Why? Because the volcanoes are erupting and then they're producing a lot of those gases inside. The earthquake has nothing to do with those. Why? Earthquake is the movement of the layers of the layers in the platform of the earth. So if the layers, those platforms are shifting, drifting backwards frontwards or backwards, then you get this earthquake. But has nothing to do with it. Helps us to get the deposits to out and to react with oxygen inside. But the volcanoes are the major source for acid rain. Acid rain is a combination of nitric acid and sulfuric acid. Those areas near volcanoes areas are filled with those acids. As a matter of fact, you have to have something on your eyes to protect yourself. Whenever at the rainy day, the whole nitric acid produced as the air will come down on the people. The people will then they get this acids in their skin and their eyes and their body. So the biogenic sulfur emission of oceanic phytoplankton may play a role in a global climate. Some algae, some type of trees inside the ocean, they produce some sulfur dioxide into the air, correct, beside the volcanoes. But their contribution is very, very limited. It's not that compared to the volcanoes. Volcanoes really is the measure of gases into the air. So, but some fungi, some algae, some phytoplankton, small tiny like green trees, small tiny ones, they can get sulfur compounds into the air as well. With the help of the sunlight will be like a catalyst. But in this effect, they are really cooling effect of the temperature. What's really affecting the global warming? Somebody will tell me what's the global warming is affected by what gas and why? What gas is affecting this global warming? There is a global warming. Yes. CO2, carbon dioxide is the major one. Why? Why CO2? Well, we know that the CO2 is coming in abundance. We are inhaling oxygen, exhaling CO2. However, the problem with CO2 is the density. Density of CO2 is much, much higher than air. So, and you can see those movies in the graveyard, those creepy movies, you see this in the graveyards, a lot of smoke. In the movies, you saw it. That's CO2 gas. CO2 gas has higher density, and it cannot go all the way to higher elevation. And even if it go, it makes a very thick cloud, preventing the heat coming from the ground out. The heat cannot go outside our planet. It's just containing, correct? Like you have a house without windows, without doors, and you are heating a furnace there. So what? The heat is there. It's nothing going nowhere. So you will be like, barbecued inside this closed house without windows, without doors, without nothing to escape. And that's because of the density of CO2 compared to the air density. Air is very light, goes up. The CO2 is heavier, comes down. The air on the top, the CO2 is here preventing any radiation from the heat we are producing to go out. Okay, guys? So, and I think that's chapter 2. Those are the summaries of chapter 2. And then go for chapter, I have for chapter 8. So if you want to take this quiz for this chapter, give yourself a time. Take a quiz on the last day. Do not please jump on those quizzes and then they'll affect your grade, as I mentioned before. So takeaway or conclusion of this chapter, the movement of matter and energy through system maintain the world's living environment. That's really true. We live in a planet, or I would say not a planet, but we live in the whole Milky Way galaxy on the basis of recycling. Everything recycles itself. If there is no recycling, then there will be no living inside our Earth. And maybe there is a living somewhere outside the Earth. We don't know yet. Maybe in the future, maybe. But if there is one, there will be based again on recycling. Without recycling, the matter itself, that will be very hard to live on. You cannot live with in a planet or meteoroids or stars or anywhere without the recycling effect. The recycling effect, that's the material you are using is not depleted. It's recycling itself, like energy. Energy is not destroyed and cannot produce from nothing. The energy is recycle itself. I have now, this is plasma of argon, the light, correct? Now this will not die out. It goes to another form, solar energy, wind energy, correct? So it's always going back and forth. The water flood or fall energy. So you have energies are chemical energies. All those energies are in cycle. They transform themselves from one to the other. Matters consist of atoms. As I said, we talked about this. Atoms is the smallest unit of or particle in the elements, and those atoms making compounds or molecules. And among the principal substances we can consider in the ecosystem are H2O, tap water, carbon, nitrogen, phosphorus, and sulfur. Those are the major important element and molecule. H2O is not element. H2O is a molecule or compound, but those are elements and compounds are really very important for the living sustenance in our planet. Okay, and primary producers, those are the trees, are the major contributor for the energy and energy through the glucose to our living. So this one here will I'll stop here and then I'll open it back again.